All right. Thanks for being patient. To set up a Zoom streaming is always, and at the same time, I have to ensure that everything projection is correct. It's kind of technical work. Okay, so let us continue. So in the last lecture, we talked about the general definition of probabilistic learning. What's the advantages? What are the challenges? And also what are we going to talk about for this course? And we are in the middle of going through the syllabus. So I think we have arrived at the grading policy. So we got two parts of the components. Well, we got two components which determine the final grade. One is the homework, the other is course project. Again, there will be no final exam, no midterm exam, no, not any quizzes. And in the homework assignments, we're gonna have 6 homeworks, and you might have seen the first one has already been released. It's homework 0. Right? And later you will see, like every a few weeks, there will be new homework assignment released through Canvas. And in most cases, you're gonna solve both the analytical problems and programming problems. So analytical problems just to deepen your understanding and practice the mathematical derivations we have gone through in the class. And the programming assignments just to practice your because we're doing some machine learning stuff, right? You need to implement some model or test some statistics to master those models, right? And we mentioned that we only accept 3 languages: MATLAB, R, and Python. And perhaps the most popular language right now, I mean, for machine learning and data processing is Python, because there's so many open source libraries and a very huge community in support of different libraries. But if you want to use MATLAB and R, I have no issue on that. Actually, I like MATLAB and R better than Python. But right now, most people use Python. If you don't use it, you're gonna fall behind. And in some programming tasks, I may ask you to use PyTorch or TensorFlow. The reason is when we talked about Bayesian deep learning, like Bayesian neural networks, we're going to introduce some popular inference methods based on reparameterization and stochastic gradient descent. We don't want you to implement backpropagation from scratch. That's unnecessary. This is actually the content for the entry-level course. So that's why we request you to leverage automatic differential libraries like PyTorch or TensorFlow. Well, of course, if you want to use other automatic differential libraries like JAX or what else? I forgot. that library name comes to my mouse and just I forgot. But anyway, there are other automatic differential libraries. If you want to use that, go ahead to use that. But we just don't want you to implement the backpropagation, those steps by yourself. And and inevitably, in doing those program assignments, you have to operate matrices and vectors, and to do some numerical computation. And again, please fully leverage the existing numerical libraries like NumPy and SciPy in Python, or MATLAB and R. They kind of internally support all kinds of matrix operations. Don't try to implement a matrix inversion by yourself. Unless we mentioned in the homework, you're not allowed to call high-level APIs, like one line of code help you implement a logistic regression, or one line of code help you to create a neural network model and train that. That's not allowed, because what they implemented is what we want to learn. So this is not allowed. Okay, any question regarding the homework assignments? Everyone feels good? Okay. And then we talk about the course project, right? So we got two types of course projects. And first, I think the most popular type will be use probabilistic learning approach to address any research or practical problem you feel interested in. I've seen some email asking me like, I'm a PhD student doing this, and I'm interested in this part. Can I use this as my course project? Yeah, perfect. It's really, I'm really happy to see that. I'm actually curious to see what kind of problems you're interested in using probabilistic learning techniques to address. That's something I'm excited, right? Or you can choose whatever other problems you want. Later we will talk about when we go to the course webpage, we're going to discuss about it a little in detail. And someone may feel like I don't want to do any project, right? And we have another choice, paper reading. So you can choose 3 papers in this area, right? From the recent conferences, like we restrict the papers. Those must be published in top machine learning venues and no later than 2005. I don't want you to read too old papers. And you can pick up any 3 you are interested in, but there must be some probabilistic learning method. If you're doing non-probabilistic learning, please don't choose them. And you can just read through these papers and make sure you understand the detail, and then return reports. Like later we'll discuss about what kind of content we expect in your report. Right? And then you can also choose the journal papers if you want, but that work amount I think is much bigger. So for the paper reading, for the course project or for the research project, you need to create a GitHub repository and submit a midterm, a final report. Okay? So midterm report and final report just to tell us what's your progress and what's your final results and what's your discussion, and no more than 6 pages. And for paper reading, before the midterm, you need to submit 1 paper summary, which is at least 2 pages. Okay. And 2 reports before the final, before the end of the semester, for the other 2 papers. Okay. And we request you to write at least 2 pages. This is just to make sure that you really read those papers seriously. Okay. And don't copy the sentences from those papers. Otherwise, you won't receive any credit. Right? So now let's go to the course project web page to see a little bit more details, to give a sense how we're gonna grade your projects. Right? So like here, again, we list the 5 top machine learning venues from which you can select the 3 papers you want to go through. Or you can choose to read journal papers. And also we give a list of excellent journals in probabilistic learning. But again, the workload is too much for this. If you're really interested, please go ahead to that. Although we do not strongly recommend you to read through like lengthy journal papers. Right? And how are we gonna grade your reading project? So basically, we're gonna break the grading into several milestones. So first, you need to make a choice of papers, right? So we're gonna soon release some kind of deadline and to remind you to choose your papers. So please, maybe in 2 weeks, and please decide which papers you want to read, right? And notify the instructor the papers you want to read. Right? So, but if the papers do not fit the probabilistic learning topic, you will be asked to select a new topic. Okay. And then in the midterm report, which were 30 points, you need to submit the summary of one paper, right? For the final reports, you submit the summary of the remaining 2 papers. So, so here is our request for the summary. Right? So first, each summary should have at least 2 full pages, size 10 font, single spacing. Right? So, and this is just to ensure you really read the paper seriously, not just quickly skim it and then and then throw out the summary. That won't count, right? So first, you're gonna give a brief introduction to the background and the motivation of the paper. So why do the authors of the paper propose their methods, models, algorithms, theorems, whatever, right? Well, what kind of problems they want to address, right? And then how do they formulate problems, right? So they want to do classification, they want to do regression, they want to do dynamic modeling, they want to prove some symptotic properties, whatever, right? How do they formulate the problem? Then tell us the technical contributions of this paper. Okay. For example, what's the novelty of the model? So they propose a new novel modeling. They develop a faster algorithm. They and so on, right? So so you can see that this part actually takes the biggest portion. That again, you need to make sure you understand everything, right? Otherwise, how do you write that? Right? And then evaluation, right? How did the authors conduct the evaluation, right? How do they, based on what do they conclude that their methods work, right? And the methods beat state of art, right? And you need to be clear, how do they conduct the evaluations? What are the baselines? What are the data sets? And what are the experiment protocols, right? What is the measurement, like root mean square error, area on the curve, classification accuracy, F1 score, and so on. You need to be clear about that. And finally, we want a little bit critical thinking. Right? So if you read papers, you just read papers and you forgot it. Right? So actually the most important part, especially for PhD students, is the critical thinking. Right? So they present their work, right? Their work is showing effective in some problems, in some applications, under some scenario, right? But no method, no models, no algorithm can work in every scenario, right? What's the underlying hypothesis did they make, right? Are there any sloppiness underlying that, right? Are there any deficiencies, right? What is the problem, right? Which scenarios perhaps that method will fail, right? So you need to think about that and tell us your thought, right? And once you identify the deficiency of the methods, is often the start of a new project, right? This is often how researchers and PhD students conduct their research, right? Looking at papers, looking at set of papers, they found, okay, those bunch of papers, they all make a simplified assumption, blah, 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 but this assumption can be problematic in another scenario. That scenario is not trivial, right? So to address that problem, we can adjust the model, we can propose a new one, we can develop a faster algorithm, whatever. Right? So many researchers are motivated from looking at deficiency of the existing work. Okay. And here I want to emphasize again, the summary with the less than 2 full pages will not receive credit. So please be sure to write down. You write more, which indicates that you really do this seriously. Okay? And don't copy sentences from original paper. Right? Write everything, write own understanding with your own language. Okay, any question regarding the grading policy of the paper reading project?
So here, you're talking about the efficiency of the proposed method, but can we critique how they evaluate the method?
Yeah.
Maybe the evaluation matrix is not strong enough, or the experiment.
Yeah. That's perfect. That's perfect. What I said is just to give you some example how to make a criticism, but you can criticize one paper in all aspects as long as you want. You see that actually no work is perfect, and even those classical works or like best papers, they all have a variety of issues. And the problems of the academia is that people are trying to hide those issues. Otherwise, they won't be able to publish. So as a researcher, you should be able to dig out the issues. And because those can motivate your own research or project and make you to advance that field. Right? Hopefully, in the future, the academia will encourage everyone to discuss the problems and issues of their work. But right now, I think that everyone is just trying to advocate their work and trying to say their work is is perfect. It solves everything, but actually it's not. Any other concerns about the paper reading project? Okay, perfect. So now let us talk about research project. And research project, I think most of you guys might choose a research project. This is my previous experience. So for a research project, you can use probabilistic learning approaches to explore or address any research task, right? And you can also, oh, by the way, paper reading can only be done by a single person. You cannot form a team to read 3 papers. You have to read the 3 papers by yourself. Okay, but for a research project, you can form a team, and each project group consists of almost 2 students. Right? So you can find a partner. You two together can discuss and develop probabilistic models and algorithms to apply in your research. So here are the grading and milestones. So first, please create a GitHub repository and update and maintain your project. Right? And here is how we gonna break the grading. Right? So first, tell us your project team. Right? So notify me and the TM who is your partner, or you just want to do a solo project. Right? Don't miss that, because I think in the machine learning course I taught last semester, one student he just forgot to inform the project type. Although at the end we know he's doing a Kaggle project, but he missed some points and he got B+. He's supposed to get A minus or A, but he missed a few points, and that time I cannot do anything, right? So don't miss that. And then during the middle, right, we expect a midterm report, which worth 30 points. Right? So submit at most 5-page description about your project, and the size is 11 font. Right? We don't want you to write too many. This is different from paper reading. Concisely write the following. Right? First, briefly introduce the problem you want to solve using probabilistic learning. Right? For example, if you want to classify weathers, or you want to predict mosquito behaviors, just tell us, right? And then the motivation, right? Why do you want to use learning techniques, and why not using traditional or existing methods, right? And and especially what kind of benefit do you expect the probabilistic learning will bring, right? For example, I got another. Actually, we actually launched a program. It's called Deep Learning program, which helped to. This is kind of master program. Some traffic department in Utah provides some data. Right? They have a demand that you have some cameras which can automatically detect tires or any other small barriers suddenly appear on the roads. Right? So once you detect that, and they can send out, teams to help get rid of those stuffs. Otherwise, it might cause accidents. So they found that deep learning is really a good techniques of doing that. They can detect that object very accurately. Right? This is kind of a problem. Right? So if you want to add a little bit more things, like you want to add some uncertainty estimate on top of deep learning for detecting an object, right? And then decide if you want to give a warning message or not, right? So this is just one example. Right? So you can find out whatever interesting problem you want and just express your motivation. And what you have done to reach your goal, right? So in the midterm, we expect that you have done some preliminary trials or tests, like with simple models, like even Bayesian linear regression models or Bayesian logistic regression models. That's fine, right? Don't just say, okay, I have collected data. That's the in the middle. You should have do something. You should have done something. And what's your detailed plan for the rest of the project? Okay? And then reference to the literature. This is how typical a technical report should include. Right? And then for the final project, that will be due by the end of the semester. Right? Again, please submit a report up to 6 pages. Again, 11 fonts, 11 size font. Don't make the font too small. And which should be structured as a small research paper, right? And we expect the following sections. Again, problem definition and motivation. What problem did you choose and why it is important and interesting, right? And then your final solution, right? So what is specific models and algorithm did you develop to address your problem, right? You use neural networks, use Gaussian processes, or use general adversary neural nets, right? How do you train your algorithm, right? You tell us you implement it with say PyTorch and use ADAM optimization. What's your learning rate and how do you conduct the training? Oh no, this is the experimental setting. Sorry, but anyway, the solution you should provide your own solution, your methodology. You should give a clear description, right? And then how do you conduct experiments, right? And what kind of data set? Where is the data set from, right? And what kind of experiments did you conduct to test your method, right? So generally, you should do some cross validations, and you should choose some metric like MAE or log likelihood and whatever, right? And you should include a few baselines, right? You cannot just show, okay, my method, I got my accuracy to be 70% accuracy or 75% accuracy. This is actually not informative at all, because we don't know. Unless you say, okay, my test accuracy is 100%. Otherwise, it's not informative. Right? You always need to introduce some competing baselines and showing that how your method performs against that one. Right? If you performs better, wow, that's a good thing. Right? But if your model turns out to perform worse, that's fine. Don't be worried. We won't deduct your points because your method doesn't seem to work well. Because this is research, right? And research does not guarantee success, right? And I often face failures for different projects, right? And even sometimes I feel the idea is really cool, but it doesn't work, right? So just to be honest, just to honestly show all the results and give your conclusion. You can say, okay, my method beat the competing methods. Okay, it's good. I'm really comfortable. I'm really excited, right? But you can also say, okay, after those trials, I found out our method doesn't work, and this might be the reasons 1, 2, 3, 4. That's totally fine. And then say a few things about future plan if you want to continue the research. I mean, it's not necessary to continue research, but if you want to continue research, what will be the next step, right? You think is reasonable. Okay, any question about our policy about the research project? Everyone is comfortable? Okay. And again, if you want to do a theoretical project, okay, because there won't be some experimental evaluation. So we're going to merge these two sections, the solution and experimental together to give 40 points in total. And again, the final report should include a GitHub repository that links to the implementation. That means we're going to look at your implementations. That means we need to ensure that you're actually doing something, right? That should, you don't need to. The final report is not made by our mind, right? It's actually made by our actual efforts.
It's possible that we choose the tree methodology and compare them for experimental evaluation.
Oh yeah, that's excellent. Yeah, I mean, you mean choose some paper and reproduce them, right?
For example, choose the tree method of the machine learning.
Yeah, you can do that. But you need to specify what kind of problem you want to compare, on which you want to compare those methods. Any other question?
If we choose a theoretical project, then what does it mean to have a link to our implementation?
Even you compare that, you should write some script, right? You should collect data, right? We need to see this.
I mean, a theoretical project you write in 3D proving interesting properties of a learning algorithm.
Oh yeah. For the theoretical, there's no in theory, in theoretical, there's no need for GitHub.
Yeah, and no implementation.
No implementation, unless if your theoretical project also includes some implementation, please include it. If there is no, if you just show a bunch of theories, wow, it's perfect not to include any GitHub. Any other question? I want to want me to clarify. Okay, so here we just list the possible topics which you can choose to do the research project, right? So any project using probabilistic learning as a critical step, all components will be fine. Okay? So the project can be one of application project, right? Some machine learning application that you feel interesting. You can reproduce some published results, right? You look at this paper and feel like, oh, this is interesting. I want to reproduce them. I want to implement them, and say if their report, if I can replicate their results, right? That's good, because this is called reproducibility issue. Right? Many papers, the numbers in their paper actually are not reproducible. So this is an actual issue. If you do that, you're contribute to the whole academia. Theoretical project, right? Prove interesting properties, a learning problem. Of course, if you're doing purely theoretical project, you don't write any program. Yeah, you don't need to attach the GitHub link, but just let us know. Algorithm project, right? If you feel like this learning algorithm, like this type of Markov chain model cover sample is too slow, I want to switch to another one. I got new idea. So the mixing of this chain is faster. Yeah, that's a perfect project, right? And also your own research. Like if you're PhD students, I'm pretty much sure you're doing research, right? With you by yourself or with your advisor, you can choose whatever your current research project to do that. I think it's good to for both your research progress and course, right? Okay, yeah, please conduct rigorous protocols for the experimental evaluations, right? Choose fair baselines, apply cross-validation for hyperparameter selection, report both positive and negative results. Again, your grade won't be deducted just because your method seems not working or seems not the best, right? Just honestly acknowledge the results and the conclusion. That's enough. Okay. And also there are other project examples we listed here, like biological and medical study, commodity recommendation, And the software security, how do you identify Android apps with malware? Sentimental analysis, right? How do you can you automatically detect people's preferences to say president or whatever, right? And spam email detection, and also there are also a lot of fancy tasks in this Kaggle competition, right? So if you look at Kaggle, right, there are a lot of data sets, a lot of tasks, right? So you can spend some time taking a look, right? So right now, I in my own papers, I often use those data sets because they're real data sets, and many of them are very interesting. Okay, any question regarding the project?
What's the deadline to choose the project?
The deadline should be near the end of the semester. But you see that we have some
choose.
milestones to choose project.
Ah.
Yeah, I think in 2 or 3 weeks. Yeah, we're gonna release the deadline for project decision soon, maybe in next week. But you should think about it right now. I mean, it's not necessary to start your project right now, but you definitely need to think which type of project you're gonna do.
Just which type or which papers?
Which type? Yeah. And papers, I mean, it's not like you need to determine in the first 3 weeks. Like it was, I mean, it happened that sometimes you feel, okay, I'm gonna read these 3 papers, but later I found, okay, another 3 is even more interesting. And can I switch to that? Yeah, if you feel like you have enough time to read through the papers, it's totally up to you. Other questions? Okay, if you have any questions or concerns, just let me know, and also let our TMs know. We can discuss later. Yeah. So now we're gonna. Oh, by the way, I want to. Yeah, I want to briefly. Yeah, I want to briefly walk through this course website. So this course website actually is in my home page, and actually includes everything, all the necessary information we have. So, and the main page is the instructor and also the time, schedule, and the office hour, and a link to the syllabus and overview and grading standards. Those are pretty much the same as the syllabus. And I think the most useful tab would be this lecture link. So someone asked me if this video is streamed online. Yes, it is. And I'm now trying to use Zoom to record all the video because the quality is good. And then after the lecture, we're gonna release the link. You can see this link, right? This is a link to our first lecture video. And later today, I'm gonna put the second link video. And also we're gonna put some reading materials here if we have. And also when we release the homework, we'll put the news of release here, right? So and then here's additional information like honor code, and also the link to the textbooks and linear algebra resources, statistics resources. I mean, if you want to review them or you want to look up something, right? No one can understand, no one can memorize all the formulas, right? If you want to look up some formulas, feel free to check your textbooks or look them from those. Look for them at these links. Most of those books are free online. Yeah, this topics is actually covered in the syllabus as well, right? Yeah, this is the project information. Okay. Okay, the last few things about the syllabus. Okay, so we got some letter grade mapping, and we do not curve your grade. We'll round up your score to the closest integer values, like 90.5 to 90.9 will be treated as 91, and 90.1 to 90.4 will be treated as 90. Right? So here's late policy, right? We allow 2 days lateness, right? 2 days lateness, but your late submission will have some penalty, right? We'll have some late penalty, like 10%. Right? So if you submit the assignment late, you're gonna automatically have 10% penalty, and then every subsequent 24 hours will have another 10% credit lose, right? And here is the letter mapping for the final grade, right? So we're gonna calculate your numerical grade and then map them to different letters, and and assignments will be posted far enough ahead of time. So I usually do not make exceptions. However, because this is a special, this is a special case and special period. If you unfortunately get some like a COVID, just let me know, right? And we can discuss about possible extensions. Right? Other exceptions, so we're gonna need the doctor's note. And if you believe there's an error in grading the homework, you can request a grading within 1 week after receiving your grade. Right? So we'll ask our TMs to regrade, but don't ask us to regrade homework 0 at the end of semester. That won't be fair to other students. Right? Homework submission. So we only accept homeworks written with LaTeX, right? Because there are many math formulas will be in the homework assignments, right? If you don't use LaTeX, I cannot imagine how you're going to type those equations, right? And here are some template, but here we strongly suggest to use Overleaf for LaTeX editing. Right? It's a free web LaTeX editor. Right? You could just create an account and then just import the template file we provided, and we provide the template text file and also the homework assignment, the text. You can just edit those text file in Overleaf. It's very, very convenient. You don't need to install anything in your local desktop or your laptop. Sorry, what's wrong with this? Okay. Any question regarding the letter grade mapping and homework submissions? Okay. Oh, by the way, homework submissions are through Canvas. Right? And unless we request you to send by email, just through them, just submit through Canvas. Right? And academic policy, well, I don't want to repeat this, but basically don't plagiarize others' homework assignments. Otherwise, there will be some bad consequences. And we encourage that you guys discuss how to do the homework assignments. But you have to write down those solutions by yourself. You can say, for example, like homework 15, well, this looks like hard, I cannot do everything. Yeah, go ahead and discuss with others, but don't post the possible solutions in Canvas, and don't copy your friend's solution. Once you got the idea, exchange ideas is totally fine, but you have to write down the derivation, the description, the text all by yourself. Does it make sense? Okay. Yeah, collaboration policy. Yeah, this is pretty much the things I just said. Right? If you kind of like feel you will inevitably kind of your assignment will overlap with other guys, right? You have to state them in front of your homework assignment, saying that, okay, I talked to him, we kind of reached to agreement how to solve that problem. We have the same ideas, blah blah blah. Otherwise, if your written if your writing is the same as the other guys, it's really hard for us to deal with that. And finally, if you have any physical challenging problems or any safety concerns, just let us know. We will refer you to the places and help as much as we can. Yeah. Okay. Any question regarding the cost policy? Okay. Thanks for your patience for this lengthy introduction of course policies, because I think although it's lengthy, but I think it's good to explain everything beforehand, right? So, but again, I'm gonna express my warning, or again, right? So please make your decision seriously, because this course is math intensive, right? And it requires non-trivial programming, right? With Python, R, or MATLAB, right? Python components may require TensorFlow, and the coding workload is not heavy, but it requires the careful debugging the mathematical derivations, right? Basically, if you don't derive the right formula, you're even not able to write any programming. You're even not able to program. And the workload can be heavy. I mean, heavy does not mean like you have to code 10,000 lines every week. It's including many analytical problems and also a few programming assignments. If you're not super familiar with those kind of things, it might take you 6 to 10 hours per week. So just to prepare, right? But of course, if you're good at those mathematics, you're good at linear algebra, well, this course might be quite relaxed for you. How we will learn, right? Yeah, let me find the pointer, a better pointer. It's really bad. This. Okay, these are pointer. Okay, so take classes to follow the math, understand the models and algorithm. I think this is always the most effective approach to take the class. So I know many students, they just don't take the class, or they just watch the videos and lecture slides. I would say, yeah, some smart, some junior guys, they can do that, but I think it's unnecessarily waste your time, right? If you just stay here and focus on the lectures for 80 minutes, right? And you don't need to spend extra time on that. What you do is just look at slides and do some mathematical derivations. That's it. That will save you a lot of time, right? Why not just do this, right? And also, and very, very important, derive the math details by yourself. Right? I'm gonna show you those formulas. I'm gonna give you this, and if you're seriously taking the lectures, it might be easier to you to follow the whole logic. But if you really know the models, if you really understand the details, you have to do the math derivations by yourself. Use your hand. So, and finish the homework assignments and to deepen your understanding, right? And implement and debug models and algorithms by yourself. Okay? Finally, class project to enlarge your vision and practice your capability. Any question? Okay. Again, the course focuses on mathematical foundations, modeling, and algorithm details in probabilistic learning. That means we're not going to talk about how to apply machine learning or probabilistic learning to specific tasks, like a variety of cool tasks you may have seen in the news or whatever. Like it's not our job. We'll be very happy if you have some someday like you're gonna apply or develop those methods and for those cool tasks. I would love to hear your story, but our job is not to show off this. Okay. So that will make the course a little bit dry. Right? I will try to share some of my thoughts and also gossip about the machine learning applications and interesting applications, but of course this is not our focus. Right? And it's also not a tutorial about how to use specific machine learning tools or libraries like scikit-learn, PyTorch. This is not our job. It's actually, as an undergrad students, I believe everyone has capability to read the documentation and pick up those libraries by yourself. You guys should be good at that. And how to program debug, right? And we believe that you have already had some programming experience. You're not scared about writing several lines of code. So this course is an advanced course for students who want to study ML in depth or quickly get to the frontier research of probabilistic learning. In other words, this is not a preliminary course or some entry-level introduction of statistics. This is also not the goal of this course. So that being said, the content can be hard for someone if they're not prepared for this. Right? That does not necessarily mean that you're not good. I mean, you're just not prepared. If you want to consider this course later, like you can take some pre-course like introduction to data mining, mathematical foundations of data science, which is taught by my colleague Jeff Phillips, and also other courses that will give you the flavor. I know many of you are doing good in undergrad study like math or those kind of stuff, but in those kind of area, we're thinking of doing like math and abstract things in vector matrix space every minute. So it's very natural for us to write down a bunch of formulas and do some matrix vector operations, trees, and determine those kind of things. And you might need some time to adapt to that kind of flavor. But if you feel like this is a kind of awkward, this is kind of make you throw up, it's not necessary to take it right now. You can definitely consider it later. Yeah. Okay. Don't take this course if you're struggling with linear algebra, calculus, or basic statistical concepts. If you're struggling with linear algebra, that will be very, very painful. As I emphasized in the last lecture, the basic terms, notions, and objects are vectors, matrices. When I write down something, I naturally assume this is either a vector or matrices. I can do a lot of things like by default. I won't be able to, I won't have enough time to write down those matrices and vectors element-wise and tell you, oh, okay, how those elements are interacting with elements in other matrices. That's not effective, right? We need to introduce the high-level operations on top of those vectors, matrices, and what kind of meaning of that. Right? And also, this course is quite abstractive. Although I'm trying to amuse you with some cool and fancy applications of machine learning, but the whole course content is quite abstract, quite dry. If you're sick of mathematical symbols, right, you soon see tons of mathematical symbols, mathematical derivations, proofs, and calculations. If you're sick of that, and don't take this course at least now. Right? And also, don't take this course if you do not feel good in programming debugging. And yeah, this is very important because this is a CS course. It's not a purely theoretical course. You have to do some programming to verify the model and to see how it works in real data set. Right? Okay, we assume that you are not scared of math, statistics, calculus, and calculations. You're comfortable with abstract symbols and matrices operations. You can pick up MATLAB, Python, R quickly, even you have never used them before. And you enjoy debugging, you enjoy step in, step out, and print out the messages, then look at the changes of your matrices elements to detect if there's any problem, right? And also you can quickly learn how to use TensorFlow, PyTorch, and all other open source libraries by following documentation and searching for the online examples. And most important, please be prepared for enough efforts for this class. But again, I mean, this 2 to 6 hours per week might not be applied to everyone. But just to give you some kind of worst estimate, please consider it seriously. Okay, any questions so far? Everyone is comfortable with that? Yeah, I really don't want to. I mean, why should I should say those things? I don't want to make you frustrated, but we do want our students to succeed, but we don't want you to feel like tortured. I don't want that. Right? So maybe it's not the right time now to take that class, but after if you prepare and you're still interested in that, you can consider to take it later. But if you take I mean, in the appropriate course at wrong time, I mean, that will make this meaningless. Right? It's not necessary to waste your time. Like everyone is busy. Right? But anyway, I mean, from homework 0, if you have already you haven't done that, please start it as soon as possible. It's kind of like a comprehensive. That's not comprehensive test. It's just a kind of test, a background check. And it has 2 effects. First, help you to review the background, and it forces you to open your textbooks. Right? You haven't seen those materials maybe a long time ago. And second thing is you can check if you're comfortable with that. If you feel like if you're pissed off by those problems, maybe it's not the right time now. Any question? Okay, great. So now we're gonna talk about real content right now. So we're gonna start with some basics review. And again, this is just because of time limit, right? We cannot give some comprehensive or in-depth review of everything, right? Because there covers too much. We just want to point out some key concepts and computational rules for the guidance, because those are really important. And once you know those concepts, or you're aware of those concepts or computational rules, then you can look up the references. Right? We can give you some excellent references, especially like matrix derivatives, those kind of steps. I tell you what's the idea, what's the mechanical way to compute that. But I cannot help you to memorize our rules. I will give you the dictionary. You just open the dictionary and do the calculation. That's it. Okay, so we're gonna start with the matrix and vector derivatives. So let me switch to iPad, because that will be better to show everything. Yes. Oops. Let me make it larger. Okay, looks better, right? So we're gonna start with matrix and vector derivatives. How many of you have done this before? Take the derivatives with respect to vectors and matrices. Oh, nice. Looks like that won't be very painful, because previously there are always students complaining, why is it so hard? I've never heard that before. Okay, so So before we introduce the rules to compute matrix and vector derivatives, we're going to introduce several standard notations on that. Right? It is used in the academia for a long time, so that when you see those symbols, you should associate automatically with the types of objects. Right? So usually, for non-bold letters, they are indicating scalars, like small a, b, x, y, even like a small, non-bold capital letters, b, d, g, and Greek letters, they usually represent scalars or numbers. And for bold small letters, they usually represent vectors. Like small a, small bold a, small bold b, small bold x, small bold eta, small bold gamma, and you can write a lot. So they usually represent vectors. So when you see that, you can imagine there's a vector standing in front of you. And for bold capital letters, they usually indicate matrices. Like A, big X, big Z, big gamma, and so on. A big omega, sigma, you see a lot. Right? So when a matrix, for a matrix, you need to consider, you need to always keep track of its shape. You can imagine it's n by n matrix, right? What's the size of first dimension? Was the size of second dimension? And you're doing derivations calculations. You always need to pay attention to their size. Okay. Now let us look at the definition about matrix of vector derivatives. Right? So it actually defined very similar or almost the same as the scalar case. So it comes from, from my point of view, it's better to, it's more intuitive to explain in like a Taylor expansion theory, right? So for the most ordinary case, like suppose you have a scalar input, you got a scalar output. So this scalar y you view as a function of x, right? So we know that for a small perturbation of x, which we denote by dx, y x plus dx equals to yx plus some term a times dx, right? Plus some higher order terms, right? We usually write it as higher order term, meaning that when dx is enough small, these higher order terms can be ignored, right? This is a basic calculus, right? Everyone should have learned that in the undergrad course. Right? So, and accordingly, this coefficient for dx is called the derivative. And we define partial y over partial x as this derivative. This is our definition. Or we can write it in another way, right? which is, this is what I'm favoring. I can write dy equals to a times dx, right? A is the derivative. So now, yeah, everyone is comfortable at this, right? So now let us move to a little bit more complex case. Suppose now you have a vector input and you have a scalar output. So basically you got a function, right? You got a function of multiple variables, which is this case. Right? So you got n variables. Sorry, this should be number, right? This should be scalar and xn. So this is x. So x is a vector, n element vector, right? So your dx will be vector as well, like dx1 to dxn. Now you can still, according to the Taylor theory, you can still write your y function at x plus dx equal to yx plus some vector a times dx and plus some higher order term regarding this dx. And be aware this dx now, this is a vector. In other words, this higher order term is actually a function of vectors. But here, we should be where dx is a vector. Okay? And A is actually a row vector. Okay? So A dx, then A times dx will give you a scalar. Okay? So now we define our partial derivative of y with respect to x, which is the partial derivative of y with respect to each element in x as A. Again, we can write this in another way. We can simply write dy equals to A times dx, but A here is a row vector. Careful, because doing this, you need to always pay attention to the size and shape of your vectors and the matrices. Okay, so now let us move to even more general case. Suppose you got a vector input, you got a vector output. Okay. So your vector output consists of m elements. That means your y dimension is m dimension, right? And your vector input consists of n elements, your n dimension. Okay. Again, the derivative of the input is still an n-dimensional vector. Okay. So now, when we write the Taylor theory, Taylor expansion, right? Your y function at x plus this dx can be expressed as yx times some matrix A times the dx. Then plus some higher order terms. Again, this higher order terms is regarding the vector dx. But here we need to pay attention to each term in this equation. So y is a m-dimensional vector, and yx m plus 1 dimension, right? And dx is n minus 1. No, n times 1, right? N by 1. So what's the size of A? M by n, right? So what's the name of this matrix A? Jacobian, right? Everyone has learned that before. Right? So this is how we define the partial derivative of y over partial derivative of x, which is called Jacobian. Okay? So the Jacobian shape is m by n, where the rows corresponds to different elements in the output, and the columns correspond to different elements in the input. So let me write it down, right? So you can see that each element is actually the partial of summa yi over partial of summa xj. Okay? So we define our partial derivative as the Jacobian A, and a more convenient writing will be dy equals to A times dx. But again, please be aware the size of these three terms. Okay, this is our definition of the partial gradient and derivatives. Right? So in all three cases, right? Scalar input, scalar output, vector input, scalar output, and the vector input, vector output. We got our derivatives: scalar A, vector A, row vector A, and matrix A. Right? So we define the partial gradient as derivative. And this definition is consistent with the definition of Jacobian. Right? So if you just look at this case, right? Actually, this covers all the cases. Right? If you want to look at scalar input and scalar output case, you just have your y vector dimension 1, your x vector dimension 1, right? So you go back to this, right? if you have a, vector input, but scalar output, just make your output dimension is 1, right? Then your A matrix, A matrix is always n by n. In this case, that will be 1 by n. That's why this vector is a row vector. Okay? And in general, it's just n by n. Okay? So here is just the notion of gradient, but there is another notion of gradient. So you will see some books or references, they do not define the derivative as the Jacobian. They define the derivative as the transpose of the Jacobian. Yeah, that's this kind of inconsistent notions kind of confused me for quite a while when I studied those when I reach out to this topic. Right? But here I want to advocate the Jacobian definition. Why we should stick to the Jacobian definition? The benefit is that we can apply the chain rule in a very natural way. So let us consider this case, right? Suppose you got a vector function y, right, n by 1, right, is a function of x. X is also a function of z, right? So y is n by 1, and x is n by 1, z is q by 1. Right? So we just follow our definition, our notion of gradient, and see how do we calculate gradient, right? So we know that partial y over partial z should be the Jacobian, so the size should be n by q. Right? So to do that, of course, it's a composite function, right? We should apply the chain rule. So we should first calculate the partial derivative y with respect to x, right? And then partial derivative x with respect to z. Right? So now, partial derivative y with respect to x, according to Jacobian, the size must be n by n. Right? The row column numbers should be the number of dimension of m, and column dimension should be dimension of x, right? And accordingly, and similarly, partial x over partial z, this is another Jacobian, so size n by q. So you can see that you just multiply the first Jacobian by the second Jacobian. The matrix multiplication, they're consistent, right? That's why we like the Jacobian notion of the gradient. But some books, if they use the transpose of this Jacobian, you cannot apply the chain rule from left to right. You have to do it reversely. So basically, if you go back to this case, right? So if you use their notion, your partial y over partial z will be partial x over partial z times partial y over partial x. Unless you're right-handed, you're left-handed, I don't think this is really natural. Right? But you can check the matrix sizes. Only doing so will make it convenient. But there are some some kind of convenience of doing this. Why? Because imagine like y is a scalar, so that means y is 1. My m is 1, right? And x is vector, so n might be bigger than 1. Then the transpose of Jacobian will be a column vector, okay? Because n by m, right? N by m now, and m is 1, so now it's n by 1 vector. So this kind of consistent with your view of the gradient vector. Right? Suppose you got a function of vector x, right? Is n by 1 vector. So you want your gradient to be an n by 1 vector as well. That's how this notion arises from. But again, if you stick to this notion, if you want to apply the chain rule, you have to do it from right to left. And if you want to use Jacobian, which is more traditional, well, I'm more favored. I'm more. I kind of prefer more about that. Then you just need to be aware that when you do a gradient vector, it's a row vector. Yeah, just keep that in mind. Right? But whichever case, right, to calculate the derivative, to calculate the gradient, the key is to get the derivative, right? No matter notion you want, right? If you want notion one, well, you just use the notion. You just use the derivative. If you use the notion two, well, you take the transpose of the derivative. But in whichever case, what you need to do is to derive this term, right? If you can manipulate your functions and terms, and finally you get such a form, like dy equals to a, some a matrices times dx, you get derivative. And then you get your gradient. So the calculation of or derivation of matrix or vector gradient is essentially a way to arrive this form. And how to arrive at this form, right? You need to recursively apply the chain rule to get the target derivative. So let us use some scalar case as an example, right? Because everyone is familiar with that. And you see that the computation or derivation procedure for the matrices follow the same way. But here we just give some quick review, right? So if you want to calculate the derivative of dy, right? So according to the rule that the derivative of summation of two terms is the summation of the derivatives of each term, right? So we're gonna get dy equals to d3x times d1 over x squared, right? And d3x, which is really simple, is 3 dx, right? And this guy, well, you can view this x squared as a whole, right? And so we're gonna take the derivative of some function 1 over z, right? So take derivative, that will give you minus z minus 2 dz, right? If you take derivative of this guy, right? So z is x squared, right? So you just got 1 minus x minus 4 dz, right? And then your z is x squared, right? So your dz is further 2x dx. Right? So now you just multiply this guy, and just merge all the term. You got your final derivative, which is 2x minus 3 times dx. Equals to this, right? So now you got your gradient, right? So how do we calculate or derive matrix derivatives? We follow the same way. Okay? We follow the same way, and we just decompose the components of your function, right, into different components, then take the derivatives recursively until you can arrive at dx, and then you just merge all the coefficients or terms multiplied to your dx, and you get the form dy equals a times dx. You get derivative. Does it make sense? Yeah. But the problem is that we need some basic rules to do that, right? We know that, okay, d3x equals to 3 dx, right? It's kind of like by default. Right? We know that d1 over x equals to minus x minus 2 dx, right? This is something we're all very familiar with, right? It's already in our blood, right? But for matrices, what's the basic rules? Do you have for example, if you want to compute derivative of x inverse, what's the basic rule to get that? If you want to compute derivative of the determinant of matrix, what's the rule to get that? So fortunately, we have already had a lot of such basic rules. what you need to do is just apply them, recursively apply them. You don't need to memorize that. Although, because I have done this like 10,000 times, most of those basic rules I have already memorized. But if you don't memorize, don't worry, just there's a reference, just check, right? So going back to the example I just mentioned, right? How do you compute dx inverse? This tells you, right? It is a minus x inverse dx x inverse. If you want to compute derivative of the determinant of a matrix, follow this rule, right? dx determinant because the determinant x this is scalar and trace x inverse dx. So what's the trace? What's the trace operation? Okay, perfect. Yeah, I don't need to introduce what is trace. Okay, and also many other like derivative of a log determinant. Right? You should memorize this because this is really common in probabilistic learning. Because for example, you often need to deal with multivariate Gaussian distribution, and that means you have to compute the log determinant of covariance matrix. And if you want to estimate that model, you need to calculate the gradient of the log determinant of the covariance matrix. So this is very common use. This is trace x inverse dx. But anyway, like the scalar case, for matrix and vector derivatives, there are a lot of like basic rules help you to reduce the complexity of problem. You just recursively apply those rules until you get some thing times dx. And then you just merge all the coefficients, vectors, matrices, which multiply with dx. And then you get dy over, finally, say, b times dx. Then this b will be your derivative. This one? This one? 1, 2, 3, 4, 5, 6, 7. Are you seeing this one? Oh, this is called Kronecker product. It's called Kronecker product. Yeah, Kronecker product. This one is called Ivan-Weiss product. That means if you do x circle y, it just means you multiply each element of x with each element of y. Yeah, and I'll give you guys the references. They give the definition of all of this, including the Kronecker product. I'm not gonna explain what is Kronecker product. You can take a look at the definition. It's very easy. Okay, so let's stop here today, and next week I will start with some examples. I will give you these 2 examples to show you how I recursively apply those basic rules to derive the derivative. Hopefully that will be helpful for homework 0. And also, if you have taken a look at our Canvas, actually our TM released one piece of a tutorial. He made that tutorial before, giving more practice and also guidance how to do that. So I will highly recommend you to go through that tutorial if you need some help.